Hey everyone, today I'm really thrilled to share the remarkable progress that we have made in the Crime Data Analytics project. Our journey has been one of innovation, dedication, and collaboration, all aimed at harnessing the power of data to enhance law enforcement strategies and ensuring the public safety. In our quest to predict crime rates effectively, we have dwelled deep into the realm of machine learning, exploring a multitude of models and employing ensemble methods to refine the predictions. Last week marked a significant milestone as we tested several regression models, meticulously evaluating the performance to identify the most accurate predictor. And I'm delighted to announce that the rigorous testing and evaluation after everything, the support vector regression model emerged as beacon of accuracy, surpassing all other ability to forecast crime rate. This achievement not only validates our effort but also heralds a new era of data-driven insights for law enforcement agencies and policymakers. So this I'll show you the data analysis and the testing part that we did. So we tried different types of testing throughout the testing phase, and after testing the code using SVR and ensemble method, SVR came out to be the best. And our accomplishments in data visualization facilitated by tools like Seaborn have provided invaluable insights like complex landscape of crime data, empowering the decision makers to make decision with clarity and precision. We have added all types of visualization that we created using different Python codes here. We also did some visualization using Excel that is also provided here. And as we stand on the cusp of completing the phase of our project, this journey has been really good. And I think the team's dedication to excellence has brought us to this moment where our project is completed. In closing, it was a really good experience. We came to learn a lot of new things. There were some challenges that we faced, particularly like the crime rates were not good at the first, and the accuracy was a little low. But as we keep on developing the testing phase, we were able to overcome all of those challenges. And there are lot of things that we came to learn out through this project that contains the model evaluation, the ensemble learning, and the hyperparameter tuning. So this is all. Um, Together we have achieved a remarkable milestone, and together we have done this project. Thank you so much.
Hey everyone, today I'll be giving you an update on my current task and progress we have made so far. It's the last week, and my current task involved finalizing test cases and scenarios, and along with that, also conducting unit testing, integration testing in Google Colab, and helping through with it. Moving on to the successes and solutions. So, I implemented an ensemble learning techniques to significantly enhance crime rate prediction accuracy, identified new patterns within the dataset, providing valuable insights for analysis. We have also successfully developed and trained a random forest regression model to accurately predict crime rates for 2024 and created a comparison graph between predicted crime rates for 2024 and the mean crime rates for 2023, aiding in performance evaluation. Along with that, we have also created a lot of visualizations for our data analysis. Moving on to the next slide, we have implemented the ARIMA model for MAE calculation. In this case, our MAE is like 6.40, and here is the code for the MAE calculation and for implementing the ARIMA model. Moving on to the next slide, we have the code for predicted crime rate versus actual crime rate. So this code involves creating a chart on Matplotlib, using Matplotlib and creating a chart between predicted crime rate and actual crime rate. So using our machine learning model. Moving on to the next slide. So this is the graph that the previous code generated. It's the predicted crime rate for 2024. And moving on, the predicted crime rate for 2024 with random forest regression is 198,745.11. Moving on to the next slide, we have our testing phase with ensemble learning. So here we also created a classifier with using ensemble learning techniques, and we use like 5 different algorithms in it: random forest, SVM, gradient boosting, adder boost, and extra trees. Here's the code for this. Moving on to the next slide, here's the result for the previous code, and here you can see the predicted crime rate for 2024 with ensemble learning. These values, and for RMSE for ensemble learning are 29926.02, and means MAE for ensemble model was 21703.11. Moving on to the next slide, we have RMSE and MAE score comparison for our testing phase. So here we are using random forest regressor, and we are calculating MAE and RMSE scores for both of the cases for all the 5 algorithms. So you can see the RMSE scores for random forest, SVR, gradient boosting, ADA boost, and extra trees, and you can see the same for MAE scores for them. Moving on to the next slide, we have here we are fine tuning the SVR based on testing results. So SVR gave us the best output and the best prediction results, so that's why we are fine tuning it in this slide. And here's the code for fine tuning it, and we're using extra parameters like CV, scoring, and verbose. And here's the result. The RMSE for SVR model is 21982.23, and MAE for the SVR model is 18826.20. Moving on to the next slide, we have testing phase report. So in these results, we evaluated the performance of several regression models for predicted crime rates. The models considered were random forest, SVR, gradient boosting, ADA boost, and extra trees. After training and testing each model, we compared their performance with two metrics: RMSE and MAE, mean square error. And these are we are displaying the results for uh, all the algorithms here. And moving on to the next slide, we have, so among all these models, as I explained earlier, SVR performed the best, so which because it achieved the lowest RMSE scores and MA scores. To optimize the SVR model further, we performed hyperparameter tuning using grid search CV. The best parameters found were C value was 0.1 and epsilon value was 0.01. After fine tuning the SVR model, the RMSE score was 21982.24 and MA was 18826.20. Moving on to the next slide, we have done some data visualizations, and this visualization was between CRM CD for embezzlement, petty theft, which is like $950 or under, which has we have seen that it has noticeably lower than, which is noticeably lower than VICT age. Moving on to the next slide, we have weapon description, which includes strong arm, hand, fist, feet, or bodily force has noticeably lower than LON. Moving on to the next slide, we have premise CD, which involves 101 and 501, which have noticeably higher time occurrences. And you can see the graph here. Moving on to the next slide, it's the last chart, where is the status description, which states that invest count accounts for majority of the area. And that's it from my side. Thank you.
Good evening, Professor. This is Ekamjot Singh, and I'm going to explain what the budgeting was for this week's assignment, which is week number 12. So the total budget that we set was around $12,000, and in total we spent around $11,900. So we saved around $100 in this week's project, and you can see that the budgeting was divided into 10 phases: the initial data collection, data approval, requirement gathering, project proposal, project charter, and so on, so on. So the most that we spent on the phase was the project charters phase, where we went a little over budget. We spent $300 more than the expected. So we spent $1,500, and the budget for that phase was $1,200. So so this was the most expensive phase for this week, and now I'm going to explain to you what I have done in this week's. So I have created data models for visualization purpose and created more visualization technique to understand the data better. And I have collaborated with Shashwat and Dhruv on the task related to machine learning and graphs and conducting unit integration system testing and manual testing. So I have identified relevant libraries and techniques for various industries, facilitating more effective data analysis and visualizations. So, thank you so much, Professor. Have a wonderful evening. Thank you.
Hello, now I'm going to explain the communication plan. Here it shows our sponsor, our project manager, our team members, our way of communication, messages, method, frequency, like weekly, daily basis, hourly basis. Next, it's our consumption of our hours as compared to the previous week and the current week. Here the histogram shows the clearly representation of the hours consumption. The total of them is 8,950. Next, here are some challenges like crime data prediction. The challenge here was the crime, like the predicting crime rates accurately is a vital for effective resource allocation. The solution, like we use advanced machine learning techniques such as assembled methods via voting recognition and fine-tuning hypermatics. Next is outliner detection challenge. This challenge outlines higher or lower values in our dataset which can distort analysis results. Solution, identify and handle outliers by visualizing the data with plot box, histograms, and consider using statistical method to detect and manage outliers. Next is development phase challenges. Here, the challenges was like we were overcoming obstacles in the development phase which can hinder progress and effectively time completion of our project. Solution, we effectively work together with project management strategies, allocation resource, we allocate resource efficiently, we maintain open communication channel with the team to address challenges promptly. Now it's the individual status report. Here my current task was the finalizing PowerPoint presentation and incorporating additional aspects into projects such as lifetime expectancy analysis. Next, some successes and solutions. We added lifetime expectancy analysis as an additional aspect to the project, enhancing its scope. Like we successfully created comprehensive PowerPoint presentation for the project documentation. Next, we provided support to Shashwat through the tasks related to machine learning model development, like comparison of the graph, unit testing, integration testing, manual testing, and all of those stuff. Next, the lesson learned. First one was the model evaluation. It was throughout the rigorous testing and evaluation, we learned the importance of model evaluation, which helped us to identify the most effective approach. Next is assemble learning. It was the implementing assemble learning technique which proved instrumental in enhancing predictive accuracy. It also highlighted the value of combining multiple models. Next were hyperparametric tuning. Here, it a fine-tuning model parameter significantly improved performance, emphasizing the importance of hyperparameter optimization. Next is communication. Here, regular team meetings facilitated effective communication and collaboration, ensuring alignments on project goals and tasks. Here are some recommendations like continuous improvement, exploratory analysis, user feedback, documentation. All of these are the self-explanatory terms which are very easy to understand. Yeah, thank you so much. Thanks for our team members for their dedication and collaboration throughout our project. Special thanks to our instructor for their guidance and support. A gratitude to our client for ensuring and trusting us with the project and providing valuable insights. Next is some appreciation to all stakeholders which involved for their contribution to the project success, and we are looking forward to continuing our journey for innovation and collaboration. Thank you so much.